This video is on integration using residues. In today's video, we are going to solve a problem based on residue theorem. So in this video, we are going to evaluate integral z by z minus 1 into z minus 2 square into dz, where c is the circle, that is mod z minus 2 is equal to half, using residue theorem. So we have to use residue theorem for solving this function. So this is nothing but integral f of z into dz. Here clearly f of z is given as z by, this is z minus 1 into z minus 2 whole square. First of all, we have to find the poles for this given function. In order to find the poles for this given function, we have to equate the denominator to 0. That is, z minus 1 into z minus 2 whole square is equal to 0. So if I equate z minus 1 to 0, see here, z is equal to 1, which is a simple pole. So we got a simple pole. And next thing, if I equate z minus 2 whole square to 0, so here z is equal to 2 is a pole of order 2. Is a pole of order 2. So we got two poles here. The first pole is z is equal to 1, which is a simple pole, and next one z is equal to 2 is a pole of order 2. And see here, our circle is given as, see if you observe this one, this is mod z minus 2 is equal to half. So we have to check whether these two poles are inside or within or on the contour. So here this is nothing but, see here, so this is 0, this is 1, and this is 2. And this is I, and this value is 2i. So this is minus I, and this is minus 2i. So clearly this is minus 1 and minus 2. So we have to take 2 as a center, and we have to draw a circle. So this is the circle. So I am showing you clearly. So this is the circle. So here this is x-axis and this is y-axis, and these are the points. We have to take 2 as a center and half radius. So we have to draw a circle. So 2 is within the circle, and see 1, this simple pole is outside the circle. So this is outside and 2 is within the circle. So we have to find the residue for the point z is equal to 2. For finding the residue at point z is equal to 0, this is residue of f of z at point z is equal to z0 is nothing but 1 by m minus 1 factorial into, this is limit z tends to z0, this is d by dz power, this is m minus 1 into z minus z0 power m into f of z. Clear? Here the order value here is 1. The order value is equal to 2, and the z0 point is equal to, the pole point is equal to 2. So if I substitute here, then the pole value will be the residue at the point, residue of f of z at point z is equal to z0. So here z0 is equal to 2, which is equal to, the order value is also 2, that is 2 minus 1 factorial into limit z tends to 2, this is d by dz power 2 minus 1 into, this is z minus 2 square into f of z. So what is f of z here? So f of z is nothing but, this is z by z minus 1 into, this is z minus 2 whole square. So this is z minus 2 whole square. So I can easily cancel these two and make a derivative. So here 2 minus 1 is 1. So this will be limit z tends to 2. This is d by dz times of, this value is z by z minus 1. So this is of the form u by v. For u by v, the derivative here is nothing but v square, v u dash minus u v dash. So this will be limit z tends to 0. This is v square, that is z minus 1 whole square. I am leaving v for one time and making derivative for u, and again I am leaving u and making derivative for one time. So what remains here? So here if you see, the next step will be, this will be limit z tends to 2. This is limit z tends to 2. This is z minus 1 minus z by, this is z minus 1 whole square. If I cancel these two and substitute 2 in place of z, so this will be minus 1 by, this is 2 minus 1 whole square. So this is minus 1 by 2 minus 1, 1 square, it is again 1. So the value here is the value here is minus 1. Therefore, we got the residue value of f of z at point z is equal to 2 is 1. The residue value is minus 1 at the pole value 2. Therefore, according to our residue theorem, so we have to apply residue theorem here. Residue theorem is nothing but, according to our residue theorem, we have integral f of z dz is nothing but, integral f of z dz is nothing but, this is 2 pi I into the sum of the residues at interior poles. So here the interior poles are 2. Therefore, this value is 2 pi I into minus 1. So this is minus 2 pi I is the answer. So the value here is minus 2 pi I. Therefore, what is our f of z here? So f of z value is nothing but integral f of z is, this is z by z minus 1 into z minus 2 whole square into dz value is minus 2 pi I. This is how we have to solve. Thank you so much for watching. And again, if I repeat this one, so here it is the function. So first we have to take the function and we have to equate the denominator to 0, so that we are getting the two poles. One is a simple pole and another one is a pole of order 2. So this is a circle given. In this circle we have to check whether these two poles are within the circle, on the circle, or outside the circle. So let's get started to check this. So this is the graph and we have to take half radius and we have to draw a circle. So 2 is inside the circle and next 1 is outside the circle. So we have to find the residue for only the point 2. So at the pole value z is equal to 2, the residue process is this one. So we have to take the order value 2 and the pole value as 2. And after solving and substituting the value of z as 2, so minus 1 is the answer. So according to our residue theorem, integral f of z dz is nothing but 2 pi I into sum of the residues, that is 2 pi into minus 1. This is minus 2 pi I is the answer. Thank you so much for watching. This is also very important. Please practice and pass it on to your friends.